Cool. Looks like we're good, I think. Yep. Looks good. Okay. Good morning or good afternoon or good evening, wherever everybody is in the big world. We're back again for more, basically just to keep working on what we got working just at the very end of the last stream, which was sending like relatively raw video over the network and then having our little server receive that video and serve it over HLS or HTTP live streaming. So that's cool because how that worked was that we would just, in like about 100 lines of code, have a, pretty simple, pretty robust HLS server, which I think is pretty cool. So we're going to do that. But first, somebody sent in a patch to our SCTE35 package. So what I want to do is just look at that and apply it, review it, see if everything's okay. And just check it out basically. So I'm going to go to here. Let's have a look. So what this patch does is it finally gets previously in our SCTE35, if I go to maybe something like here, was it? Yep. So in our splice, we've got this guy down here, which is like a built-in sort of error correction thingy. Very badly explained. So the way that was implemented before was we were using this huge table of values, magic values, that somehow somebody generated. We were using it from the Comcast's Go package for SCTE35. The problem is that it wasn't really reproducible. So I think that that's an important bit of software is you want it to be reproducible, right? Because it's just code. So we really should just be able to do whatever we want with it. I said, yeah, like there should be a way to generate it, but I didn't have time to do it because we were powering ahead with HLS and doing all sorts of other stuff. But here we are, somebody awesome by the name of Black Falcon has come in and written this little patch for us, which is awesome. So it deletes like lots of lines of code and they have this little thing. I haven't actually tested it yet, but let's give it a go. So we've already applied the patch. Let's run this thing. Okay. So how can equals make, yeah, nice. Okay, cool. Let's go here. Awesome. Wouldn't mind knowing what that actually is. So that's the first thing that I'd think about. I know it's like a polynomial, but which one? I remember reading the Wikipedia article, and there were quite a few. So there's that. Now let's go through. So we're looping through each entry of the array. We're shifting So we're getting the index that we're up to, and then shifting left 24 positions. Okay, so we're getting the, okay. So what we're doing is we've actually got 32 bits. So let's say we've got, you know, OX, LF, and then if we just do 8, 16, 24, 32. So what we're doing here is that we started just with what is that? That's just an integer. Yeah, right, okay. So we started with something like this, and maybe with some number of, I mean, I guess in Go it's 64-bit, but it depends on the implementation and the processor, architecture, whatever. But point is that we're getting this value afterwards, and then those are all zeroed out. And then if we're checking if OX80, it's 1, 2, 3, 4, 5, 6, 7, 8. If it's set, then you shift, you get your value, you shift it 1, and then you XOR it with the polynomial, which is this bad boy here. Otherwise, you just shift the thing along 1. And then you set it there. So, and then at the end of it, you have your table. So this is how the thing's generated. So we start from 0, right? And then we go, so the first value of the, yeah, well, let's just go through one by one. So we start with 0, and the whole thing must be 0 because we just don't, yeah. Starting at 0, and then obviously nothing's set, and then we're shifting anyway, so it's zeros all the way. And we get that. Cool. Next up is, so we'll have 01. That'll be the next. Yeah. Let's go through. Okay, so we go, yeah, that's the value that we get. We go through, we loop 8, and then we say if the index does not equal 0, then do that, and then XOR it with a polynomial. Otherwise, shift it to the left 1. So in this case, yeah, that is true. So we're doing XOR with a polynomial, and then we add it, and then we move on. And then we're resetting the CRC every time. Okay, so for index 1, it should just be the strat value of the polynomial, which is this thing. And yeah, right, nice. That is what we get. Okay, this seems to make sense. We've still got this gross thing, but to have this thing that generates a table is awesome. Now, the fact that all the tests pass is great, right? Because in all of our tests, we have, where are we? In our tests, we've got test data. Oh no, we just got it here. All right. But all of these have our checksums, like a value for CRC32 in there. We've got all this sort of stuff. So the fact that we're getting like, yeah, I mean this, yeah, so it works, right? Otherwise we'd fail hard. But all our tests pass, so that's, I'd say that's pretty sweet. Now, the problem is that we still need to keep this copyright notice there because we still have this bit here. So we've done the thing that generates a table, which is just awesome. But yeah, now we don't. The only thing that I think we need to do is just update it to like get other, like just write what this magic number is. So I think we can get that from that article on Wikipedia. Yeah, let's just go there and then CRC. Cyclic, that was it. And then if we look for this, we should get, yeah, this is it. Ah, comes from the TV standard. MPEG. BZIP. Ah, that's why they, yeah, okay. So that's why Black Falcon's written this BZIP thing. It's the same as used in BZIP. Now, whatever happens now, every time I see this gzip or bzip, I think, shit, like, is it, you know, the XZ, you know, the one that got done by that crazy, what was the name of the hacker? Gia Tan? That was amazing. Anyway, used in gzip as well. Maybe, what's this column then? Normal, reversed. Aha, okay, so maybe the constant could be something like polynomial, like poly. But not exported because we don't care. Normal. CRC32 or... Let me see. Okay, now if this is in gzip, that means that it's probably in the Go standard library. Let's see what they call it. Just as a kind of a yeah, little experiment. And in bzip, right? Because gzip and bzip are both in the Go standard library. So let's have a look there. Oh, sorry, we got some chat messages. Your GitHub link in the description doesn't make sure it's not. Oh shit, yes, somebody. Okay, sorry about that. Let's have a look. Oh. Yeah, sorry. Okay. Do I need to go to the actual... So we're just checking the... Apparently our GitHub link is busted, so let's fix it up. Oh, they're... Look. Oh, they're... Look. Shit, sorry, we got there's an echo there. Okay, let's fix that thing up. Yeah, thanks for pointing that out, Yummy. Oh, what? Okay, that's... Oh, that means I'll need to fix them on all of the... Okay, we can go back here for them through it fails. No, that's all good. No, this is it's been great fun. Okay, that. That should be better. I'll just put that here anyway, just in case. Yep, there we go. Put that there. Okay, and then I'll pop out the, I haven't got the YouTube chat open, but I do have it open now. Oh, I can just do that. Awesome, cool, thanks. Okay, let's do this. Cool, cool, cool. I can close that. Let's make sure. Okay, yeah, looks good. Looks good. All right, so where were we? Yeah, we were working on this patch from Black Falcon. So what I wanted to do is just look at the, I'm going to grep for this, we go, where have they got that in? Compress, right? Geez, let's say. And looking for something like that. No, thought they might, but maybe not. Oh, look, they have, it's in a standard library. It's just, it's in a standard library. We don't, maybe we don't even need any of this. After all that thing from Comcast, let's have a look, yeah? So new IEEE 802 Ethernet. Okay, let's have a look. This, what? Hash, CRC30, there it is, yeah. How about that? Well, this is how about that? Let's do this then. I think, yeah. Are represented in reversed representation. So we might, that might be a, let's try this thing. Let's try and swap it over to use the package from the standard library and yeah, see how we go. I can't believe that. Okay, so we're going to dump that to CRC32. Oh, actually, let's see where the callers are. So we're going to do... Hi there. YouTube chat is finally back. Was it gone? Ah, okay. All right, so, yeah. Oh, whoops, sorry, I didn't have that visible. I was going to switch how you do. Hey. Sorry, I didn't have that open yet. See, I'm only just having my first coffee, so I'm a little bit slow. Usual to go. Google indie company. Not sure what you mean there. Google indie company, like calculate CRC32, verify. All right, so let's India. Oh yeah, man, you know, Google, it's tough, you know, Google are doing it tough, right? You know, like they have, you know, the economic crisis, cost of living is really impacting Google too. Yeah, that's actually never called anywhere. So let's have a look at calculate CRC32. Is that the only place? All right, this is where we test 32. Okay. Just going to check now what we get out of this thing. Yeah, it's still just a uint32 anyway. So if we check some, yeah, that's the one that we want. It's actually all we need. So let's try that. So this CRC is really going to be, what do we want? CRC32 dot checksum. Okay, so this is CRC32 dot checksum. Ooh. I think that should be it. Oh, yep. Okay, all right. Let's start our formatters and stuff. Yep. Aha. Okay, not quite. Yeah, but yeah, thanks for typing. Thanks for saying hey. How are you going? I'm going well. This is yeah, it's good to be back again now. Yeah, with the hashes mostly match. Yeah. Well, I think what's happening here, because this isn't the checksum, this is the... Yeah, I haven't actually done this debug print really well, but it's the last 4 bytes should be off. 1, 2, 3, 4. Yeah. Now, I think the reason is that we're doing this IEEE polynomial what we want is to... Okay, so what's happening is, I'm pretty sure is we're getting, let me put this, yeah, so I'm gonna put that there, or, yeah, put that there, okay. In the standard library, in the Go standard library, they use the reversed representation. That's what it was documented as doing. Reversed reciprocal, okay, so just reversed. CRC32. Okay. So we may be able to, instead of using this value, use this value. So let's see in the library whether we can use that one instead. Yeah, I think so. Yeah. Here we go. Make table. Yeah, this one, right? And then we go and we do, so make table, and then we do a checksum using the table, right? Would that be? Yeah, that looks better. Hi, Kai314, how you going? Yeah, that's cool. Yeah, nice. Okay, yeah, let's do that. Wow, this is great. Like, this is, I'm so happy. This is going to delete so much code. It's the best feeling, man. Best feeling. Okay, so we're going to go here. Thing is that we kind of want to keep it there, so let's just do the CRC32 table equals, yeah, and then let's go from there. New, make table, so all right. And then whenever we want to do it, we'll do a checksum using that. Yeah, okay. Let's do it here, and we go CRC table checksum. I don't like the name of that, but anyway. The data is going to be whatever's in buff. Checksum, whoops. Do that, and then actually would like to call that checksum. But anyway, we'll leave it like that for now. Oops. Oh. Pointed to table. Almost. Nope. CRC tab. No, it's, let's make sure. CRC32 checksum. No, not quite. Layout. Actually, polynomial. Yeah, that isn't, yeah. is by far and away the most common, except in SCTE35. So that's our constant, yeah. And then we go checksum, presented by table. Big endian, which is what we want. Presented by the table. Must not be modified. Quite get that. We want that checksum. Sorry, that checksum, but we got this checksum. It's got to be something to do with the order of the order of it or something like that. So it says here that polynomials are represented in least significant byte first form. Let's do this again, just out of curiosity. Four. So if we do that, okay, now let's do it with our own table. Yeah, I think that's a great, yeah, I think it's a really good idea. See, that's different again, right? So we got, that's the checksum, so this is our table. And then this is from the, you know, from the standard library. We got, let's do, oh, yep. From the standard library one, we got this. So that's kind of interesting. All right. Yeah, let's reverse it, right? So let's go, let's keep that. And then, oh, okay, so we'll go, is now going to be OX. Hi, Lucas. What are we working on? We're working on the SCTE35 package. Somebody sent through a patch for to do these to do the checksums, but just a little while ago we actually found that there's doing these CRC32 checksums, it's actually available in the standard library. So yeah, because I realized that, well, actually this checksum is used in gzip and bzip and stuff like that. So actually we don't need to write any code at all. We just need to provide the sort of this like seed polynomial value. Yeah, but oh yeah, thanks, Miguel. So yeah, let's do that and see. No, not quite. However, look at this, Miguel. So what we got was the same value that the standard library gives us. So let's see the checksum. Yeah. So let's try that again with I guess it's something to do with this checksum function. Update. Simple update. Okay. Wow, we've got some assembly in here to speed things up, I guess. We want the normal one. Yeah. Update, slicing update. Append, read, append, update. We want that one. Or this one, but let's actually, yeah, no. We're going to want to look for that one. Where's that simple update? I know we're just in there. Oh man, are we actually going to do simple? No. Generic? Simple update. Okay. Whew. Given a table that was previously computed and still makes out. Oh, Jesus. Getting a little bit deep in the weeds here, I think. Fuck. Oh, it was so close. Would have been so handy. Don't use hardware acceleration, similar so in the users. So the slicing by 8 is faster than use a bigger table. Okay. What's up with the color scheme? The color scheme of the editor? That's just the default one. I installed Acme. Oh, the text editor is Acme. Yeah, this is Acme. Yeah. I have a link to it in a link to a bunch of information about it. There. That has info about the editor and a link to like a video that sort of has a fun walkthrough of it, stuff like that. Hey, the dev. how are you going? What's my degree in? My degree, the VR called Nightmare. Hey, it's all good, you know. They're actually really similar, I think. Yeah, they'll kind of come from ed, you know, from ED. My degree is in medical science, so I wanted to go into medical research, but when I left university, I was traveling and doing fun stuff, and then eventually I got a job in IT, like doing desktop support, that sort of thing, help desk, and yeah, just from there kept going with it. That was almost 10 years ago now. Yeah. All right. Yeah. Damn. Do with the way that the maybe we need to do, maybe we should do this #32 and then although is this just implements IO reader and writer. Yeah, 100%. Yeah, yeah, sorry, I should put this here. So this is they're talking about it. Yeah, look, people sharing stuff online and doing stuff online helped me so much. And yeah, like I'm actually a pretty big noob compared to a lot of the people that I've been watching and have read about over the years and stuff. So yeah, yeah, this is just about, you know, me trying to inspire people to do other stuff too, you know, because that feels good. That's pretty much it. Plus, I'm also looking for a job. So if anybody knows any people doing video work that, you know, would like to have somebody on the team, then I'm here. Yeah, that's it. Yep. Yep. Hash functions, a writer, sum, and return the resulting size, not change the underlying hash state. I think data previously has second imported as original form. Yeah, okay, so this Hackmuck's team is hiring in San Francisco. Yeah, that's the thing. In Australia, I mean, Australia is so beautiful and it's so, like, the lifestyle, you know, I really enjoy living here, but yeah, there seems to be lots of jobs in tech in, you know, Europe and in the USA. Yeah. I think that the Alex, oh, that's from up here. Yeah. Okay. make table CRC tab. Oh shit. Oh no, I've done, oh no. Hold on. Let's do this again. CRC, nah, look, I think I fucked it up. Ready? CRC32 dot, look, make checksum. Yeah, I think it's gonna be. Different again? What? Oh, we've got something totally different now. So the checksum that we're getting now is like our sort of Miguel's. You get this. What we want is actually this. Yeah, it does. Yeah, that makes a lot more sense. Absolutely. So from here, this is, I'll put this as CRC normal, and this is where are we getting this? Where are we going to get this from? This is, I guess this is going to be it would just be so nice from a, you know, from a maintenance and just sort of general, like, you know, software perspective to just, yeah. Yeah, that's it. I could just iterate through every single, you know, uint32 and eventually we'll get something, right? What about so there were these other ones. Okay, there were these things here. There was a reversed reciprocal, reverse reciprocal. Why don't we try them? The only reason I'm thinking is because maybe the way that this make table actually works is it's assuming maybe that this is, you know, that this or whatever is in a certain order. So let's throw these things in. So this is reversed reciprocal. And then okay, do we recognize this checksum anywhere? I don't think so. For now, and now, okay, no, like there. This is, oh no, this is reverse reciprocal. So this is just reciprocal. And now we're gonna have reverse reciprocal. And this value is that thing. Oh, okay, yeah, and we can just run it again. Shit. Damn, we're not getting it. Okay. Now, is this the DB7? No. 8E? Internet applications. Yeah, this is okay, another idea. Okay, another idea is we could try with the table that we generate. And I say we, I mean the code that Black Falcon has made to generate the table. But then we use the standard libraries, checksum like functions. That's another idea. So instead of this, we can actually have the one from the patch, which is, yeah, this one right here, because this gives us a, you know, a table of 256 uint32s, which is what we want. So why don't we just let's give that a go and see what that looks like. And then let's actually give it a poly, and then that's a uint32. And then we're going to return, yeah, this thing. So let's do that. Looks pretty good. And then we can do this. So the CRC table now equals make CRC32 table using, and we're going to do this one. Okay. Now when we go to CRC32 here, we can actually just get our little table. Because the test cases are in value. Yeah. Yes, thank you, yeah. And then what we'll do is our table, we might have to do the type conversion on it. Let's see. Checksum using a table. A table is just a type. Yeah, that's easy. Okay. So we'll go using the what do we need again? You in a table, so crc32.table. Is it going to be happy or no? Does it want to point it to it? Yeah. Oh, whoops. Ugh. How how do I do that type of conversion? I want to do the, like, make a, let's do this, return a table. Yep, there we go. Oh, yep, and then we just take that like that. I think that's actually nicer. I think it's, yeah, make, you know, yeah. How about that? How about that? So still not there. Okay, one of the ones I want to do is, let's just see if at the very least we can, okay, another thing we can do is knock out our table code, but then keep the checksum function from the Comcast library. So let's try it the other way around. What I mean is that we'll make the table, where's our table? New IEE table, there we go. And then, oh, well, no, that won't be right either. So anyway, what I mean is that let's go crc32.make table. Yeah. And then we'll actually have our checksum function from before, which is, let's grab this out. Have that. Let's just check this file out again. Okay. So let's keep this one. Let's call this checksum. We're going to take an array of bytes or slice of bytes, and then we're going to also pass in our table. So it's going to tab, which is the crc32.table. I'm going to knock that. Oh, well, let's just keep it there for now. It's fine. And then our crc32 table is actually going to be crc32.new table with the constant of that. I'll make table, wasn't it? And then, yeah. We don't want that. And this is also unused anyway, so we can get rid of that. So checksum is going to see crc32.table, so it's going to be tab. Oh, yeah. Okay, and then here we're going to do checksum. Oh, and that's just that. Okay, ready? 3, 2, 1. What? CRC, oh, crc32 table. Ah, what? Ugh. Damn. The value we got was this. So no, it doesn't match any of the others. So I think that means, for now, might have to just leave it, I think. Which sucks, but we got this awesome patch from Black Falcon, which I think is great. Yeah. I think it's just a question of like maybe just trying to understand what this thing actually does, maybe. Which, it'll just, I mean, it's got to be the byte order. I mean, there's nothing else to it. Like, there's no other, I don't know, like it's, yeah, there's not much else going on, right? I mean, literally, in the Go standard library, it's implemented in assembler. So, you know, like, what? I mean, sure, there's always somewhere deeper to go, but, like, there's, yeah. All I'll do is just add that, grab that constant out. So we'll go like that. And then we can go poly is a uint32. And then let's use also the type from the standard library just to make it, yeah. So we'll go tab is a var tab CRC32.table. Tab I equals that, and then return tab. Okay. Then we do that, and then here, let's pass in the table as a CRC32.table like that. As the pointer, so we'll go tab, and that should do reference for us, which is great. And then we will, yeah, that should be all right. Let's and oh yeah, we'll delete that afterwards just to keep the commits sort of clean, the patches clean and easy to read. So now that we've got this, we can do our CRC32 table is actually going to be from that, and then we'll go, let's link this actual article, or say this is the reverse of hash CRC32. What was the polynomial called? IEEE. Oh, okay. No worries, Miguel. Thanks for joining us. Oh, Black Falcon's here. Oh, mate. Hey, JMG _______. How you going? 715209. Hi, how are you? Oh, where we go? Oh, mate. Hey, 715209. Thanks so much for the subscription, mate. That's awesome. I hope it's helpful. I hope that this sort of thing also helps other people. So thanks so much. Later on in the stream, we're going to be setting up our sort of self-hosted stream. So these kinds of subscriptions should help that kind of thing working. What's bleed purple? Oh, oops, am I missing something? Oh. Chat. Yeah. Hey, Assad, how's it going? Good morning. Okay, I think let's do this. Oh, geez, guys, thanks so much. It's awesome. Okay. Yeah, Black Falcon. So, thanks so much that you're here. This is so. We're already saying thanks so much for your patch, but we were trying to see if we could use the one from the standard library. We discovered it was there, but I'm totally out of my depth with this sort of thing. Let's do this constant. Right. I should just it's a table. So let's do a checksum. Looks pretty good. Okay, let's save that one. What is checksum? Aha. So, yeah, now that there's a few more people here, I think, or maybe different people, we were, the user Black Falcon very, very kindly and very awesomely sent us a patch to, instead of, let's just have a look at it here. Can we see that? Yep. So instead of relying on these magic values here that came from, I don't know where, Black Falcon wrote just a tiny little function that generates it for us. So now when we generate the checksums in SCTE35 messages, which we do right at the very end of when I'll just show you. So this is our splice, which tells you, so the command says, hey, this is an ad break, or this is a, or it's the end of an ad break, or it's like time for whatever, some error or whatever. And then, yeah, you got things saying when and how long. how many there are, that sort of thing. At the end of the message, there's a checksum. The idea is that when you're receiving this kind of messages over the network, and not even over the network, like over satellite or radio, the idea is that you can do this, have this like really tiny little checksum there to make sure that you've actually received the message properly. Something like that anyway. And it's actually used in a lot of places that I didn't know. It's used in like gzip, bzip, it's used in Ethernet. It's, yeah, a lot of places that I had no idea about. So yeah, this kind of gets us closer to being able to get rid of the sort of Comcast stuff. Yeah, which is awesome. So our CR kind of just joined at the end of the review. Yeah, yeah. No, well, we've found that there's this in the standard library. And yeah, I don't know whether we could use this one. We did a bunch of testing and yeah, didn't understand why we weren't getting the same values out as we were getting when we either use the static table or the table that's generated, you know, from your function. So I had a quick look actually at the standard library and how, you know, the code there, but then we got into assembly and I said, nah, I'm so out of my depth, it's not funny. So yeah, but by the way, it all works beautifully. So what we're going to do is we're going to polynomial representations. Is that the one we want? Yeah, and then do that. There we go. I'll just check. We don't, I'm just going to delete that now because we never used it. And then here we're going to, let's do this CRC32. What? Oh, yeah, here we go. From our CRC tab, CRC32 table. So let's just check some B using a pointer to this. Nice. There we go. Cool. Just do that. that's fine. They'll know that's from a standard library. Awesome. Now, I would say that we are good to... Oh, no. We're going to need to understand maybe a little bit of the code there before we're good to delete this other copyright notice. That is... Yeah. Yeah. All right. Let's go. Oh yeah, yeah. You know, it's just a different way of doing it, right? Yeah. And like to learn as well, right? I mean, man, I've learned so much in 2 weeks. It's crazy. Just did that. And then, yeah, so this, I'll just commit this and then we can move back onto HLS. I wonder the issue that we hit was because of the bit shift of the algorithm. In the Huh. Okay. This is in the bzip. Yeah, okay. In the bzip. 472. So really the update CRC32. So this is the function that's called when we actually is that? Yep, so that's done. So if we go CRC, okay. what do you think? Where is our chat? So how do you think that the value uint32, what is that? Oh, that's out, yeah. Wait, no, value? Oh, from the table, yeah, okay. So what I'm thinking is that, how do you think that this logic here, and that, I guess, compares with this in here? Let me put the font in monospace for everybody. Sorry, I usually do that at the beginning, but I forgot. What's in that? But yeah, I guess it will be. So I think my thinking where it's coming from is that we made the table like this, and then we would do calculate our checksum, and then like this right now passes all the tests, so we get all the values that we expect, and we've got a bunch of different tests in there. But then when we switch to trying to use it from the standard library, not from the BZIP, but from from the CRC32 package, we get different checksums. Now, yeah, but even if we gave it the same polynomial, so I guess there'll be something to do with, yeah, but anyway, like I think that this is already like, this is way better. And then we can even just look at this. Bang, we can just do this. And we can even do that. Great. Let's just fix that one up. And while here, remove, even better. And really here, we should put, the difference is OXFF, that is from the algo. Yeah, okay. So if we go here, BI. Okay. So, okay, yep. Yeah, I get you. Yeah, because that's from, yep. I understand, yep, okay. yeah, that byte, yeah. All right. Well, and maybe then either way, I guess it's try and move on, I suppose. We can come back later too. This is already just so much better, which is just awesome. So yeah, thanks so much for submitting that. That was, yeah, you're a genius. Yeah, I guess you've, no, totally, man. It's, yeah. How did you, have you done this sort of thing before? No. What? Okay. Did you just, I don't know, then how did you, yeah, okay. Yeah. Cool. Okay. Yeah. Uh-huh. Interesting. Yeah, okay. Oh, yeah, I mean, yeah, you know, video is, yeah, it's kind of, yeah, video is, yeah, it's kind of fun like that. Yeah, exactly. Yeah. And I think it's something that is still, how do we say? Yeah, I think it sort of tests like with latency, and there's a lot of technology there. Whereas I think with a lot of web development, the actual technology there is, like, of course, there's some crazy stuff going on. But technology-wise, I think really it's, with video, you just hit the technology issues straight away. Whereas, with a lot of web, like, I don't know, with those sort of web apps that you see around, it's a lot of it is to do with actually knowing the business really well, knowing the problems really well. Whereas in video, you just hit, like, problems very quickly. I don't know. Yeah, it's different kind of problems, I guess. Okay, so look, I think that's oh yeah, let's push it up, 'cause I think we're done now. Let's just see. Oh yeah. What is I do it recall? This is Acme. So I have a links to some stuff in if you click that link, that should take us to, yeah, so there's a bunch of, this in particular is a fun walkthrough. Yeah. It's a really fun editor. Actually, so in 2 days' time, I'm actually doing a talk at the Sydney Go meetup. So there's a bunch of people that meet up every month or two to talk about the Go programming language and just stuff. And they wanted me to do a talk, so part of it will be about Acme. So I'm going to see if I can stream it or at least record it or something. And then, yeah, that might be fun for people because I get lots of questions about the text editor. All right. Sorry, I forgot where we were. So let's do this. Cool. Okay, let's send that up. And move on to the next bit, which was, if I remember rightly, serve our play. Okay. So let's, what I'll do is I'm going to demo where we got up to last time. Because that was a few days ago now, and I can sort of remember, but sort of not. What we did was normally I would draw this on paper, but I'm gonna, so one last thanks to Black Falcon for sending that through. Okay, yeah, so let's work on what we were doing last time. So what's normally happening is maybe I can draw it and like literally hold it up in front of the camera or something. That might be easier. So we're going to go here from OBS, and that's actually going to FF, and that. Oh no, I forgot. I actually drew up a diagram already. Give me a sec. Thought I did. Yeah, this is it. Okay. So this is what we actually got going last time, which I was surprised we got going in the time that we had. So if you ignore I'm holding my hand in front of it, but if we just ignore this bit down here, how these sort of, right now, how this stream is working is we're using OBS right here, and we're making an RTMP connection actually to this little ffmpeg command that's running here. And what this thing is doing is that it's actually just doing like a T writer by making two other RTMP connections out to one to Twitch and one to YouTube. And so we're streaming to both YouTube and Twitch at the same time. There's a bunch of like software as a service things doing that offer this sort of thing, but I mean, this is like a, you know, this also works too. Yeah, and there's not too many flags in there. I actually posted about it on the mailing list. So anyway, and then from there, Twitch and YouTube, they do a thing called they demux it. So they turn it into like, you know, they take out the bits of video and the audio, and then they put it back together again into this MPEG transport stream container in the case of Twitch. And then that uses, and then players, like people watching it in their browser or in an app or VLC or MPV or whatever, will fetch the files over HTTP from a playlist file. And that combination is called HLS. YouTube's basically the same, except they use different container and a different sort of reading like protocol, but it's the same idea. Now that's all really cool, but you know, we are only like a little, you know, let's say like a small operation, and we're doing stuff by like, you know, learning how streaming works from scratch. So on Friday, we got this thing working. Instead of making RTMP connection and going out like that, we could actually just write raw MPEG transport stream packets over a Unix socket and have this program read from the socket and then serve HLS directly from there. And this thing actually works. So I'm going to do it on my local machine first, and then we'll try and serve it over the actual internet. So anybody who's watching, we could try and let's see if you can watch it too. So how this works in OBS is we go into here, and then there's a bit in here. And you can say, instead of writing to disk, you can output to a URL, which is really just using FFmpeg under the hood. So what we're doing is we're writing to the Unix socket to that file on the file system. We're using H.264 and AAC because that's like the standard. And there's some interesting problems that I spoke about earlier about this, but I can go into that later if people are interested in different codecs. Anyway, yeah, we're just going to be writing that just raw over the socket. You can also do it over just raw UDP. That also works too. This is what this actual physical camera can actually, that can actually do that. It can write raw UDP over the network. Okay, so if I just have our little server running, yeah, the other one is dash, yeah, mpeg dash, which we have not done yet. Uses XML, whereas HLS is just using like a new line delimited text file. Okay. HLS serve. All right, let's start up our server and see how it goes. Yeah. Of course. I'm pretty sure if mpeg dash uses XML, yeah. Okay, cool. And then we want, great. All right, here we go. So we're going to start our server. I hope this works because I was testing it before. Okay, great. So we're listening at a Unix socket in this place, and we're going to be writing out files there. I'm going to move this out of the way. Okay. Are we ready? All right, wait, let me hold this up so we can see what's going on. There. Okay, 3, 2, 1. Okay, we're writing over the thing. So now if I open up QuickTime or something, and I just go to loopback, oh yeah, and it serves a playlist M3U8, port 8000, I think, yep. Fuck. What's going on now, man? Oh, maybe is it? Yeah, there we go. Okay, we got it. It's just IPv4. Whoa. Okay. Yeah, there we go. Okay, we got it. It's just IPv4. Whoa. Hey, there we go. Okay. Yeah, there we go. Okay, we got it. It's just IPv4. Whoa. So we've got a live event going. Okay. Yeah, there we go. Okay, we got it. It's just IPv4. Oh, fuck. Okay, there's the echo. Yeah. All right. So that's cool. That works. Oh. Now, what I learned is that these HLS players, they just, so that's cool. That works. Shut up, man. I can't hear myself. Okay. Yeah. If we look at, so what we're doing here is that we're just writing out these files in 2-second chunks. And when we get the playlist, let's just save that here for now, and then actually let's do it like this. And here's our playlist. This is the file that our program is generating when it gets a request. And then the player will just go and download each of these files over HTTP. And we're just using Go's standard like HTTP file server for that. Yeah, that's it. And then now it gives us this nice little live thing here because we've set it to be, that's live, according to HLS, is event as opposed to VOD. And there's no end yet, so it just will keep going forever. So there we're going to 240. Yeah. Yeah, so that'll just, and then we're just doing some debug output here. So now what I'm thinking is I might set up a reverse proxy on the internet, and let's see if everyone else can fetch this thing and see if it, I don't know, see if it fucks up or something. I don't know. How does that sound? Does that sound like fun? Let's close that and that. Yeah, that is exactly, yep. Yeah, no CDN is fine. Okay, if you just give me a sec, I'll just set up this. And you know, who cares? It's actually my friend's server, so. This is going to be in Australia, so. Yeah, anybody who. You know, who isn't in Australia, it's going to be slow. Just quickly set this thing up. And I'm not going to show my passwords to everybody. Alrighty. Create a quick few DNS records. Or could I do a yeah, no, okay. Okay, give me a sec. Sorry, I'm just going to do this live, so we're going to Now, my friend uses the Caddy server. So caddy reverse proxy. So what I need to do is just do a thing that kind of want to force IPv6. Oh, you know what I'll actually do is, no, it's fine. I'll just do the raw address for now. It's fine. Okay, apparently it's all we need to do is to okay, I'm going to test by myself first without showing it. Oh yeah, shit. Okay, I think we're good. I might post the URL in very soon. Actually, no, you know what? No, fuck it. Let's just see if this works. Okay, here we go. Let's M38. Oh, whoops! There's a few. Oh boy. Hold up, folks. Giddy up. I'm gonna put this thing in a subdirectory because I don't know what is going on in there. Let's stop this recording. Here, let's go to all right, now let's go to our let's do that. Let's serve, just change the directory that we serve out of just because I don't want to serve my whole entire temp directory. ZeroFS. Yeah. Okay, fine. So easy. All right. So go run, and then we go temp. Okay, 3, 2, 1. Okay. Is it gonna work? Oh yeah, a few people. Okay, and I'll do it to YouTube too. Now, this probably requires opening it in, if you're not running Safari or something, you'll need to open it in like VLC or MPV or FFplay or some other thing that can read HLS. Oh boy. Okay, yeah, okay. Caddy. Yeah? Is that actually working? I can't tell. I'm not actually watching my own thing just because Oh yeah, I see. Okay, I see you all. I see people coming in with VLC. Oh, not on MPV. Okay, interesting. Should I try an MPV? Let me do the same. Oops. There we go. There we go. There we go. Oh, what? And then we're going to put OBS here, and then we don't know what the fuck we're looking at anymore. We're going to put OBS here, and then we don't know what the fuck we're looking at anymore. Looks good. Looks good. I'm actually surprised. Hold on, let's test the latency. I'm actually surprised. Okay. So this is with MPV. Okay. So this is with MPV. Wait, this is so hard for me. Just testing the latency. All right, so let's go. So this is with MPV. Wait, this is so hard for me. Just testing the latency. All right, so let's go. 7 seconds. That's with no tuning, no, no playback tuning. 7 seconds. That's with no tuning, no, no playback tuning. 7 seconds. That's with no tuning, no. Now, this is using the shortest kind of allowable segment duration in HLS, which is 2 seconds. So if anybody's looking at their player or anything, you'll see that as you're playing, oh fuck, I can't stand this. Sorry, I can't hear myself. When, if I show you, yeah, basically the playlist is being fetched like every second or so by any of the players, and then if we go to here, so we're saying that the duration of every file is going to be, we're aiming for 2 seconds, and here we're sort of fudging it and saying, oh yeah, it's exactly 2.00, but whatever. Playback seems to be fine. So yeah, and then it'll just keep on going until we hit stop recording. So interesting to see maybe how many bytes are going through. I mean, I guess we know that it's about 3, the bit rate is about 26, just numbers, so the bit rate is 2600, oh no, it's about 2700 total per second. So per minute we're doing 60, and then 162 divided by 8. So for each person we're doing about, wait, is that right? Yeah, kilobytes per minute. So that's, so about 20 megabytes per minute per person. So right now on Twitch, we've got 7 people watching. And then in YouTube, we have cool. Yeah, that's probably a core. Yeah, I think so. Because the web server is, yeah, like it doesn't. Yeah, nice, nice. So, and on YouTube, how do I check how many people are watching? I don't even know. So you go, oh no, that is, so we go to, okay, so on YouTube, there's apparently 4 people watching. Okay, so on YouTube. So that's 411. So if everybody was watching, if everybody on Twitch and YouTube was watching the thing from like literally my computer here, that would be 220 megabytes per minute. So per second, that's 223 divided by per second. That's how many megabytes? Yeah, 3 megabytes per second, which my internet connection can definitely not handle. My internet connection here is about for 20 megabits up on a very good day. So yeah, there we go. That's nice. Okay, so might as well keep it running. So ideally we'd just have this running all the time, so that whoever wants to watch and doesn't want to use YouTube or Twitch or whatever can just use their own player. So maybe we'll what we'll do is we could just set up a totally static web page that also serves HLS.js with it. So that's a JavaScript library that lets browsers, that kind of implements HLS for other browsers that aren't Safari. So that's Firefox and Chrome, right? And all the other stuff out there. I know there's a lot. Yeah, so that would be a thing to do. The next thing, of course, would be to, rather than just like smashing my computer, the next thing that you'd do is there's this mux. No, that isn't the story I wanted. They have a nice diagram that shows app. Here we go. Okay, this is kind of your typical, video streaming, or audio, by the way. Like this has got nothing to do with, and both. Anyway, so yeah, this is kind of what it looks like. So in our case, we're doing something that looks more like this. We're doing something that you typically do over a wired connection because we're doing that raw MPEG transport stream. We're going over there, and then we're kind of doing this thing where we're doing a clever trick where we're just chopping up the video ourselves just using byte counts. So if I go back to here, so where are we doing? Dump media, chan time. Yeah, this is it. Okay. So where's our ticker? Where's our ticker duration? Oh, yep. Okay. So every 2 seconds, we have a ticker that sends the time through the channel to this function here. So if it's time to chop, then it does. Sorry. it'll chop it up. If not, then it'll read 188 bytes from the socket and store that in its little buffer, which is this buffer up here. Then when it's time, it'll flush the buffer. And in this case, we're just writing it to disk, but we could actually, you can imagine we could do a whole bunch of stuff here. The trick is to always, is that we know that the size is always 188. Now, what we're actually doing is we're doing 7 of those at a time because that's what happens over UDP. That's the kind of rule of thumb. Something that can fit in a frame, I think, Ethernet frame. So now we happen to be doing it over a Unix socket, but we could actually just do it, you know, we could even do like standard IO or over like a pipe, like a FIFO, something like that. But yeah, that's our, that's it. Now, I actually found, the next thing, of course, that we'd want to do is, like, if I look at my, so yeah, I got a lot of files in here. Now, of course, I just have some other like process, either in the form of a Go routine or just even like cron, and just delete the old stuff every minute or something like that. Yeah, but I actually think this is a pretty cool little program. So one of the things that I could probably do now is I've got this old camcorder here. Actually, it's not old, but anyway, this thing can write to an IP address over UDP. And so we could actually just have exactly the same thing, but then in our HLS serve, instead of listening on a Unix socket, we could just listen on UDP and everything would work exactly the same. All we'd change is this stuff down here. So that's also pretty cool. Yeah. Yeah, that would be better. Yeah. And I think that's why we get these problems. So, but yeah, that's right. Yeah. So I think the right now it's doing iframes every 25 seconds. Every 250 frames, so that's every 10 seconds. We're doing 25 frames per second here. Oh no, that's a keyframe. Sorry, no. Anyway, point is that, yeah, how do we do that? What was I saying again? The iframes. Yeah, so I think that that's why we get this error. So when we try and play it with MPV, it kind of freaks out. Does that sound right to you? Because we're going to get these sort of no frame for a bit, and then eventually when it finds it, then it actually starts playing. Because we're going to get these sort of no frame for a bit, and then eventually when it finds it, then it actually starts playing. But yeah, here we're just doing a bit of a dirty hack. Dirty hack that kind of sort of works somehow. Yeah. So that's fun. Ah. Modern players are pretty resilient, which is awesome. I'm used to dealing with old sets of running. So, aha, interesting. Yeah. Yeah, I was doing a project for a broadcaster in Australia, and that was about finicky set-top boxes, finicky like shitty like players that are embedded in TVs, like smart TVs, and they would freak out when was that HLS? I can't actually remember now, but basically they were I had to go into the transport stream packets and actually shift the timestamps on the fly so that they could scrub properly. So yeah, I know what you mean about these sort of, just stuff that you would never think of. Yeah. You're just not used to it, right? You just go, oh yeah, like just, oh, you done that? Yeah, wow, yeah. There you go. Yeah. But you're just sort of used to like these, like these things that are constantly updated, and, they have a whole bunch of like people contributing and stuff like that. Whereas on these smart TVs and whatever, it's just like, who knows what stuff is in them, And it's like, it's sold once and they're designed to just be thrown away in like 3 years or something. Yeah, very fun. Okay, I might on that success, I might go and just get some lunch, because it's a little past 1 p.m. here in Sydney, and the sun's about to come through, so I'll get my sunglasses too. Yeah, but I'll be back in about 30 minutes, if that's cool. If there's anything else that you think that we could cover, anything else that we think might be interesting, yeah, just write in the chat or send an email to the mailing list. Yeah, I'm super interested to hear what people are working on, and yeah, like what people are up to or what people would think might be interesting. Yeah, see you I'll make it half an hour. Okay, cool. Yeah. Okay, I'll say see you in a little bit. And of course, I just want to say thanks so much for everybody who's, like subscribing and just even just watching and just chatting. Like it's great to do this with other people. So cheers, thank you. All right. We're good? Yep. Just put that a little bit like, oh no. All right. Let's get this right. Okay, this camera's heavy. There we go. Cool. All right, so we're back again to do more video protocols from scratch sort of stuff. Now, we just got our HLS server running okay. Apparently a bunch of people were watching it, which is funny. I think I saw loads of requests come in. Oh, it's actually, oh yeah, no, and we've killed our server now, which is good. Now that we've had that running, what I want to do is maybe just check that we're encoding as much stuff as we should be. Well, I know we're not encoding as much stuff in an HLS playlist as the data that we store. So I might just fill that out a little bit more just to kind of like, yeah, give it a bit more, yeah, give it a bit more substance. So I know that if we go here, so we go here, target, doing target duration, sequence, discontinuity, yep. We're doing everything in the segments, whoops. URI, you're obviously doing duration, yep. Range. I'm not doing the byte range. Let's put that byte range in now. That byte range, if I remember rightly, is actually one of the things that I would be curious to look into is the low latency HLS. That will be super interesting to see. I think as time goes on, like what I've noticed is that, yeah, like not that many people are watching that much stuff in 4K at all. So I went to a talk last week, you know, this videodev.org meetup. I might just write that in so that people know what I'm talking about. HPS.org. Went to their meetup. Go to here. Yeah, went to that talk, and that was kind of, that was interesting. One of the talks was on stereoscopic 3D. Another one asking. This editor is detailed in it's in there. I'm actually giving a talk about the editor on in about 48 hours. So, yeah, 52 hours, something like that. I'm hoping to stream that. I think that should be fun. That's actually going to be at a meetup, so there'll be a whole bunch of other talks there too. So maybe if people are interested, I can stream it to this channel, or if not, it might go to another YouTube channel, which I'll link anyway. Anyway. So yeah, as I said, low latency HLS. I think this byte range is, yeah, I'm gonna put that in there. So let's, as I said, because I'm pretty sure that's required for low latency HLS. Now let's open up our spec and see what this byte range looks like. Ah, yes, we're actually already doing this somewhere. Let's do this. So if the where is that? It's 2 in, okay. Pretty sure we have a, I thought we had a thing that does the byte range already. It should be a string method on the byte range. That would be the smart thing. Now, whether or not I've done that or not, we yeah, nice, got it. Okay, so that's easy to encode. We've already done the work. So let's go to our segment. Okay, here we go. Let's do this. So the segment.range is and then colon, and then we can just use the string. That's pretty easy. Method, so that's seg.range. Okay, it's pretty easy. Next up in our after byte range, discontinuity, pretty sure we have covered. Yep, at the top there. Key. All right, it's gonna be a good one. Specifies how to decrypt encrypted playlist segments. Okay. Okay. I'm kind of wondering whether I should just put a string method on the whole damn thing here. Like that, I mean, might just do that. So the advantage of using that stringer method is that then we can just do this kind of thing. And it's part of the standard library and it's idiomatic, and you know, if any, for whatever reason, if somebody's printing out, you know, these keys, then it'll just kind of print out nicely, let's say. So I'll probably do that. Let's just save that bit. And then let's make sure %s. Yep. Oh, whoops, no, I haven't got it. So this is the tag byte range. And make sure, feel like we're not running our tests in here, which is very bad. Okay, cool. Okay, let's go to the key. Let's write this thing out. Playlist session key is also a key. Not sure whether we need to put in the tag in there. For now, let's not. Let's just do it like a key. Let's go. So I'm going to do, let's do a string builder or something. Key. Method S quoted string. We'll do something like this. We'll concatenate it. We'll just join all the strings with a with the commas at the end. So attrs, so var attrs is a string. Okay, so here we go. Hex sequence, okay. Oh, there it is, 16 part, yep. So we can just use the standard library again for this, hex. We can encode to string, that's the one I think, yeah. Now, do we need the leading OX on that? I can't remember from the spec. Yeah, okay, so lower, yeah, okay, all right, yeah, we need the leading OX. Okay, so this is going to be OX and then the hex sequence. So then it's hex.encode to string of the initialization vector, which is the k.iv. And since we've got an array, we've got to turn it into a slice, because that's what we take. So we do this little trick here. Hey, next. Is the actually let's just go to Scotty 30. No, I want the key format, just a string, okay, easy. Format versions. quotes is another quoted string containing one or more positions, or separated by the slash. Aha, interesting. Okay. Interesting. Wonder why we're doing uint32 there. I mean, why? If it is not present, its value is considered to be 1. Okay, well that means we can omit it. Whoops, and we haven't checked for the 0 values in any of these. Well, we know that, okay, back we go. Let's just double check. So the method is absolutely required, so we're always gonna put that there. This attribute is required unless the method is done. Okay, well that's fine, whatever. The value is a hex sequence. This attribute is optional. So is the initialization vector requires, I mean, see when the attribute is used. Yeah, let's put that in there and then, yeah, okay. Next up is, this is optional, so we can just check against the empty string. Do that, and then if format versions, same thing. Now this is going to be, so we're going to need to join these strings up. So we're going to convert all of those to integers. Sorry, to strings. So grab for each of them and then separate them with the slash. All right, so let's go. We know how many integers we want, strings we want. We want as many as there are of the format version is the length of that slice. Okay, and then we just go through. I2A of k dot format version I. And then once we've done, we're going to a quoted string, so we use that, and then we're going to join all those strings together we've just done with a slash, like that. Cool. Done. Nice. Okay. Key format versions. Apparently we're done. Format version URI. Format version. Cool. Okay, that's that done. Format version. Oh, well, no. Okay, and then finally we return all of that joined up by commas. So all of the attributes joined with a comma. And then we need to put this here. So let's do that, that, append. Oh, whoops, I didn't do this right. No. There we go. All right, that's done. No. Format versions. Oh. No. Oh, yeah, okay. Well, no, we can just safely, because it's a uint32, so we can easily just convert that to an int. There's no worries. Okay, there, done. Cool. Easy, easy. So that's key done. Now, when we're encoding, all we need to do is, when we get to the key, which was, I think, that's in the segment. Okay, so segments. It might be good to actually split this out into its own function, because then we can just test. Like, yeah, probably should do that. This function's pretty big. Not that there's anything wrong with big functions, really. Like, it's pretty top to bottom, but because it is like its own separate thing altogether, the segments, and it's got its own type and everything, I think we can actually pretty safely put this into its own. Then the tests are just going to be super easy, right? We just have lines that are just a bunch of segments, encoded segments, and then we just check that we can encode them and then, or so decode and then encode them back again. That would actually be good. So let's, but we'll move on to that later, because I have written down that we want to do some, like implement some tests, the way that there was a really cool talk at the GopherCon Australia. So the Go Programming Language Conference in Australia. That was at the end of last year by the head of the Go project. And that was all about testing. So I was thinking of just going through that and yeah, like using using the techniques that we find in there. Okay. So we've got here the key. Oh, segment, yep. Segment, okay. Range, are we doing range? Yes, we're doing range. Discontinuity we've done, yep. The key, okay, yep. So if the key is there, tag, I don't know what that tag is, let's go. Parse, yeah, it's all in segment, okay, so tag key, okay. Oh, we'll have to dereference that. Unless go, oh, no, it doesn't go do that for us. Anyway, the compiler will tell us right now. Something I always forget. Yeah, sweet, okay, great. dereferences. Okay, next. Let's go down to, we could do map. We've done date time, no. Date range we have done. So I've only got map and date time to do. Date time should be pretty easy, so let's have a look at map. Oh, well, that's easy. It's just, again, we've already done this stuff, so it's a byte range. Interesting. Okay, we can do that. Turning that into a string, so then where else is that byte range? Okay. I just don't, the only thing is that I just don't like exporting all these string methods, that's all. Just do it like this. It's so small that we can just do it pretty easily. Okay, so we're going to do the tag and then the attributes. So just check exactly which attributes need to be set. URI is required. The byte range is optional. Yeah. And we'll just do another little function at the bottom for now. What is that? I can't remember. Does that give you the byte count as well? Oh, yeah. Byte range. Oh no, then we can just give it byte range. Yep. Okay, so byte range looks like tag byte range. Oh, okay, like that. So we've done that, and then what else we got? Oh, just the time. Now I can't remember how the times are actually encoded in HLS. Let's have a look at that again. So ISO 8601 to millisecond accurate. Okay, so it's RC3339 milli. I think I can't remember. Time. Oh, we've got nano, not milli. Yeah. Okay, so that's fine. We can do that ourselves. So that will just. Yeah. Good, good. How are you going? I don't want to ask what time it is over there. I think it's late. Oh, no. Wait. I don't know what time zone Florida is in. Oh, there are time zones there. Yeah, so it's like... Huh. Oh, rough. No pain, no gain, mate. I want to do something like this. Then do that, and then there were quite a few people chatting before, was it? And Lucas. Yeah. No, but it's been nice. Yeah, a bunch of people been talking. We actually published a we got that HLS server working, what I'd call like at least properly. So that was cool to get that working. So there's a server. My friend has a little server in Australia that's running, and so a bunch of people were hitting that, and everything seemed to be okay. Obviously, it was slow for most people because they're not in Australia, but you know, that's cool. Yeah. So that was fun. And then we got a really cool patch from somebody. They went through and worked out the checksumming stuff in our SCTE35 package. That was very clever. I don't know, they said that that was Black Falcon. So shout out to Black Falcon. Yeah, they sent us a patch which was super helpful, and got to delete like 200 lines of code. That was awesome. We tried to use the one from the standard library. So there's actually a CRC32 package in the Go standard library, but I just we weren't getting the same checksums. So Black Falcon was saying that it was something to do perhaps with, said that there was one part of the bit shifting that was maybe out. But to be honest, now I can't remember exactly what they said, but yeah, I mean, some crazy smart guy working things out, that's for sure. Okay, there's our milliseconds. So if we do Oops. Oh, yep. Right. We're just doing the final bit of writing out the segment information in a playlist. So that's like the specific video file, I guess. Pretty boring, just going through and just writing out all the attributes, you know, with all the tag names and stuff like that. Yeah. Oops. Date time, that's it. Date time dot is 0. Then I'm going to write it out. It's an unquoted string here. Yep, date time milliseconds, okay. So ext x program date time, tag program date time. Okay, we're going to write out a formatted string with the time. It should be that our constant 3239 milli. Oh, I have a new one. Need our new lines here too. Great. Date time. Okay, so we've done key map. So let's just double check now. We go to our segment. Okay. Duration, yes. Range, yes. Discontinuity, yes. Key map, date time, date range. Yeah. You're right. Date time. Somebody asks, how do I become a programmer the same level as me? Program. I don't know. I'm not so sure about all this level stuff. I think I'm just working on this just because, you know, like, I think everybody who's been watching, I certainly feel like I've learned so much in the past 2 weeks, or 3 weeks now almost, just by doing this stuff. So, yeah, like, Roach, if you want to share what you're working on, yeah, like, send it through or something. I'm sure people, you know, you'd be surprised what people are interested in. I am. Segment duration. How do I handle database transactions in Golang? Well, I don't know if you're asking me or because we're not really doing anything related to that right now, but I think there's isn't there a, I think there's, there we go. But in general, Lucifer, have a look at this page and then the section and then you want to look at, there's this executing transactions. Is it usually you would have functions which will make database calls and you really don't want to make a database call directly in HTTP handler because you're some good, yeah, absolutely, yeah. I mean, depending on the size of the application, right? Like if we're talking something really small, yeah, who cares? Okay. To be honest, I've actually never ever dealt with database transactions in Go. That sounds crazy, but I've just never done that type of programming. Okay. Maybe, do you want to maybe share some code or something like that? And then we could kind of, we could probably look through it like that. Yeah, I think, yeah, exactly. It's often, and with those nil checks as well, I think there's a weird thing. It's like, like I hate this nil checking. Well, the sort of trick is to do it, but do it as early as possible and program around it. So there's an old Go article that is actually worth looking at. And I know this is going to sound like it may seem irrelevant, but I think this is the one. Yeah. Now this, that might seem, I can show code, but where? You might want to upload it to like a, you know, you could use something like paste.s. Usually there's websites that you can, now the only problem is that I don't know if YouTube, I still don't know why people can't post links here. So, yeah. Let me just quickly see what we can do here. I haven't changed any settings apart from like, no, there's this thing here. URL sent in live chat are already blocked. I haven't done anything. Maybe is there some setting that I've changed or something? Yeah, something like that. Or you can also, you could send it to, if you want to send it via email, we can all look at it like that. If you send it to, this, what is it? Oh. If you click that, you can just send it to that email address, and I'll see it there. But yeah, as I was saying, this is good because it sort of talks about nil checks and how to, yeah, offers an interesting way to go around them. And I think in this example, it's about like, it's about writing bytes to buffers and, IO writers and stuff like that. But the pattern is, I think, probably interesting to read. Yeah. I'm sure there's some stuff in here. I've not read that one though. Yeah, no, cool. Yeah, good luck. We'll have a look. I'll see. I've got my email open here, so yeah, all good, man. Okay. So I think that's that bit done. So let's just commit that now while we're here. And that's, yep, and then cool. Okay, let's commit that. That was a pretty boring bit of coding. What are we doing in 3U8? So what are the tags that we're working with here? Right, so all oops, and yeah, that's right. Yep. Yeah. So how it works is I just run, anyway, yeah. So there's no write, like this is just read only, but that's fine for me. Yeah. I mean, I can type just here. So the standard input from the command is here. And then this program just writes its standard output into this buffer here. Now, this is just using the Twitch's IRC or like interface, I guess. Cool. Okay, that's that bit done. So, to-do list here somewhere. Yeah. Oh, was it in here? Yep. Cool, so we've done that. And we've done that one. All right. There you go, Lucifer. You can, if you try that, you can just click that and it'll write in your email. All right. Now we've done that. Let's, I'd like to do maybe is just refactor that bit that I was talking about where we've got this segment, because this stuff would just be so much easier to test it if it was kind of split out a bit more. Let's just do that. Because we've got our pass segment stuff here, so why don't we just do it, you know, in its own thing. So go write segment, and we'll go to IO writer. Or, I mean, really we could, yeah, we could just do write. Anyway, yep. Let's just dump this in here. And then let's go like that. Oh, yeah, let's just do it in a loop. It's fine. And then that'll be really easy to test. Now to optimize, we should probably, optimize, I don't know. The recommendation is to use the strings builder from the Go standard library, from the Go strings package. That'll probably save us a bit of error handling in here. I'm not so bothered about that now. I'm more interested in the testing. So let's do a... Now, what I might do is just keep that there for a sec. Let's just put this here. So again, we're going to ignore the errors because we're not quite there yet. That's fine. P.segments. There. Nice. Yeah, have a break there. All right. Oh, no, yeah, okay, I'll save that. It's not actually zero, but anyway. Okay, nice. Okay. What I'm going to do now is open up this YouTube video and just kind of quickly skim through the tests. Might be better in text form, I think, because we've kind of got two videos going. Yeah, here we go. Make it easy to add new test cases. Yeah, okay. So that's the easiest one. So what we're going to do is we're going to have a bunch of cases here. So let's go. And then we're going to do the tag, and that'll also be the string, something like that. Oh, array. Yep, slice of. Now let's just start adding our tests. So the name of the first one is gonna, let's just do like the empty one. Right? I don't know, who knows what's gonna happen there. And then another name we're gonna do maybe no attributes. Just do ex, oh, we're testing writing segments. Let's parse. Just to get the idea. So this is, the segment is going to be something like test data. Can't remember what the test, what the segment looks like now. Ah, there we go. URI. Ah, okay. Go test. Ah, yeah, the just file. Yeah, that actually looks super interesting. Yeah. I think definitely seems a bit more focused than people using make for it, which seems very, yeah, like a bit of a hack, I think. Just seeing what the best way to test these. Yeah, so nice try, Gia10. Do that. So the segment is just going to be like that, and then we expect to get nothing at the end of it. That's encoded, or no, the output, yeah. Let's do the duration. So the value that we want to get out of here is ext_inf, let's say 10.00, here is going to be a segment with a duration of 10 time.second. So I guess I have to split these things out, but what we're doing here is we're just writing out the name of the test, like the test case. We're saying, hey, here's the input and this is the output that we're expecting when we write the thing in text format. And then down we go. So we're going to test all sorts of other stuff. We're going to go, okay, like what if the, something like that. So if we get that segment, all we want to see is this at the end of it. Let's do some other stuff. Let's try something like oh yeah. Why don't we do, you know, there's a thing, hold up. What about anybody who's typing here? Because I think you're allowed to get, oh, Tanya Angela, it's so good to see you. Oh, hey. Hi from Australia. Good afternoon from Australia, probably good evening for you in Brazil, right? It's nice to see other people from the Southern Hemisphere. Oh, yeah. Yeah, that definitely. That's kind of the thing, isn't it? Is that I think why people are using the just file and the make file and blah blah blah, blah is just to have that kind of consistent interface between projects, right? So you don't even, at some point, you don't even care or want to think about the particular build tooling for the particular programming language or operating system, right? You just want to type make or, you know, whatever, and then just get running. I guess that's the general idea, right? Yeah, yeah. There was a time like before 1.0 where it was using, it actually did just use make, and then they ended up replacing it with go build. Yeah, I can't remember. There was, yeah, I think, wasn't it? Yeah. Oh, you are I. Yeah, yeah. Oh, yeah, no. This was also, I think it was like 2009, something like that. I don't know. I was actually still in school, so yeah. Oh no, no duration. We just want the discontinuity. True, and then we're gonna want like the URI to be something like, you know, some, you know, add break dot there, and yeah, I think that's it. And then I had to I had to write crypto software stuff at work and had to use the internal Ethereum libraries to process stuff I wanted to die with. Yeah. Oh man, that crypto stuff, I don't know, like, I don't know. I don't know if anybody expected that it would ever get as big as it did. I just, yeah. Oh yeah, no, I'm not really saying. I'm just sort of thinking like how big and popular it got. Like by the time, at least in Sydney, we had ads on buses, on the back of buses, and it was like, wow, like it's really popular. Like, is it time to invest in crypto? Like on the bus in Sydney, Australia? Like, what the fuck? Hi from Indonesia. Ah, hey. Selamat siang. Siang? Yeah? Sekarang. Selamat. It's jam 3 sekarang di Sydney, Australia. Ya. Dan jam berapa di Indonesia? Or no, or berapa jam? I see. My Indonesian sucks. Sorry. Okay, so when we encode this, when we write this segment out in the playlist, we want it to look something like. We'll do some new lines now. So it's going to be xtx discontinuity. And then we'll do, actually, no, maybe we'll do it like this, and then new line, and then we just want the URI, which is break.ts, and then a new line, I think, maybe not. Okay. There's some basic test cases. Let's just run that thing, see what it looks like. So just write a bit of code to execute all that stuff. So let's go for all right, let's whoops, sorry, more people typing in Twitch here. What do you think about Scrum sprints? I used to program a lot. I didn't get much exercise and I drank energy drinks. Yeah. No, you know what? Thanks. That's, yeah. Yeah, the harp. Yeah. Okay. This is, yeah, you're right. It is bad. I don't understand what that, but anyway, I covered it was bad. What do I think about Scrum sprints? Like as in that project management style of that Scrum stuff? Okay, so let's write our test. So we got here the function, blah blah blah. I'm gonna write the And then once we've written it, we want to go if the check what we've got is actually what we wanted in the first place. So it does not equal out. And then we're going to go okay, something like that maybe. Does that close off that one? Yep. Okay, let's run it. Oop. Oh, whoops. That's got to be there. That one is there. Then that. There. Oh, yeah. Okay. Let's, yeah. No, I don't want that. There was a segment. Here we go. Where I usually use Copilot. Copilot's gotten so dumb in the past few months, it's sad. Wow, jeez. Crazy, it can get worse. But maybe it will get better. Like, if it can get worse, then maybe that means it gets better as well, right? Okay, there we go. So there's our first problem, is that the duration we want the no new line. Yeah, okay, great. Yeah, it shouldn't really do new lines, I don't think. Oh no, it is doing that, new segments, okay. Should probably fix this up. Nah, it's just a bit yucky, like the way that. Guess because, yeah, we need like a nice way to kind of format the things into strings or something, but probably what we should do is if we do that, got the thing and then a new line. Yeah. the duration. Okay, so 10. 2 new lines there. There's 2. Because the URI is empty. No. Hold on. We got 1, 2. 1. Okay, this is getting dull. All right, I need to just maybe do this properly, right? So the tag is going to be like, so first of all, this is an invalid segment because there's no URI there. That's probably the first most important thing. We should probably just error out here. Okay, cool. There we go. All right, that's already much better. Okay, that's the first thing. So let's make these things valid. So let's go here. Let's go URI is you know, big. So let's just do bunny. Yeah. Okay. Now the value that we actually want is going to be the new line, and then we're going to do bunny.ts, and then with another new line at the end. Now, apparently we're missing something here. So we got this with what we want is continuity. Oh, the duration, yeah. Oh, sorry, no, I want this one here. XC. Let's knock out this. Okay, so let's go. Whatever, I'll put some code text that later. Oh, there's some. Oh my God, I've got ext iron. Okay. Now that, let's check if this absolutely needs to be filled in too. I think it does. So let's account for that too. Just check the spec again to see whether we need to have that filled out. So it's going to be INF, yep. This tag is required. Okay, there we go. So it must be there. So when we're writing it out, let's just error out altogether. Yeah. Okay, cool. And we know that's incorrect. So in here, we're going to set a duration is going to be 30, just because why not? So we're going to have the discontinuity, and then we're going to have the ext INF as 30.00. Yep, looking good. Okay, and then the last one is our empty one, which is good. Now we actually do want that to, so we actually do want that to error out. So maybe we could just add another test case to say if it's valid or invalid. Let's do invalid equal. Let's do that here. So in this case, our segment, this one is valid. Oh, sorry, we can leave that. So the only one that we want to be invalid is this one here. So invalid is, we can just do true because it's invalid. And then what? Name, segment, invalid. Yeah. Yeah, every value has every type has a 0 value. So like for example in here, if you don't set a value, then you don't get nil, you just get false. And the same for string, it's an empty string, like, you know, yep, and then, yeah, everything. Oh, yeah, it does, yeah, because I'm using a struct, yeah, that's right, yeah, exactly, so I need to add that, yeah. Sorry, I thought you just meant like in general. Yeah, nah, for sure. Yeah, I think I'm gonna have to write this out anyway. So, because it's getting a bit. I was hoping for just like single lines, but it's sort of grown a bit too much. I wonder, it could still probably do, but I think it's just clearer like this. I was hoping to. That's kind of why I was doing that. So maybe we can do. Can we make it shorter somehow? Yeah, I think that's it, yeah. Yeah, just have it at the end, exactly, yeah. Let's do that, because I feel like I'm not super happy with like the way that... Oh no, too few values. Yeah, okay. Nah, we're gonna need it. What we could also do is just have a different set of cases that are all the bad values. So we know that like all of them should error out for some reason. So for example, we could have another test. It's like test write bad segments or something. Yeah. And then we don't have to have the ifs and stuff like that. We could actually just pump out a lot of them. Yeah, maybe let's, yeah, actually I think we'll do that. Yeah. Just because, yeah, we don't have to nest even more logic. We can just, yeah. Something like that, and then we can do, so the first one is going to be empty, and then, and then this one is going to be, no duration, and then it's going to have some other value set, let's say URI of like, video, and then something like that. We'll work on that in a sec. So we're going to go here. We've got 2 cases. Okay, blah, blah, blah. Let's see. Yeah. Oops. Hey, again. Let's go again. For underscore. We're going to try and write it out. So this is just going to be straight up like, nil error. Yeah. Should be it. Buff, where are we going? Oh, okay. Let's just do io dot. That's a discard writer. Well, io dot discard, is that it? Yeah. Io dot discard. So that's just the same as like writing to dev null. We don't care where it's going. We're just checking if we get an error, and we want to get an error on all of these sorts of things. Cool. Okay, let's. Oh. Just not Discord. Card. Seg. Ah. Got a new failing test now. Okay, here we go. Something's different. No matching segment duration. So this test here. Yeah, okay, so this is, okay, yeah. This is something that we probably should put into our segment test now. So we initially had some testing, but it was just like this one kind of one-off thing. The error that we're getting is we are dumping the playlist. Sorry, what are we doing here? We're encoding the entire playlist and checking that we get that particular segment duration. So to me, straight away, I'm going to say, hey, like, why isn't this thing failing? I mean, why aren't we seeing the error message? The error message that I'm expecting here is that there's no URI, because the segment must have a URI. Otherwise, we just fail altogether. But here we're not. We're getting some other thing. Now, this is probably because back in our when we're calling in code, we're skipping over the errors, which we I knew this would come back. It was going to happen, right? Like we were skipping over errors and it was going to come back to bite us eventually. And it has. So the caller of write segments. Okay. Cool, easy. Now here the URI just needs to be, you know, something. Great, there we go. All right, so let's go back and have a look at this overview from one of the head honchos in the Go project.
I gave this talk at GopherCon Australia a few weeks ago.
There were some AV challenges that hurt the recording, so I re-recorded this version at home. Enjoy!
This talk is about writing good tests. But first, let's think about why we write trivial test of the function. Sure, you know about table-driven tests. We encourage table-driven tests because they make it very easy to add new test cases. Here's the one we saw before. Let's suppose we have only this one test case and we think of a new case to test. We don't have to write any new code at all, just one new line of data. If the goal is make it easy to add new tests, then for simple functions like this, adding a line to a table is about as good as it gets. It does raise one question though. What cases should we add? That takes us to the next tip. Tip number 2, use test coverage to find untested code. After all, tests can't catch bugs in code they don't run. Go ships with built-in support for test coverage. And here's what it looks like. You run go test minus cover profile to write a coverage profile, and then you run go tool cover to view it in your browser. In the display, we can see that our test case is not very good. The actual binary search code is red, meaning entirely untested. The next step is to look at the untested code and think about what kinds of tests would cause those lines to run. On closer examination, we only tested with an empty slice, so let's add a case with a slice that isn't empty. Now we can run the coverage again. This time I'm going to read the coverage profile with a little command line program I wrote called uncover. Uncover prints the lines of code not covered by a test. It doesn't give you the big picture that the web view does, but it lets you stay in a shell window. Uncover shows us that there's just one line left that isn't executed by the tests. It's the line that moves into the second half of the slice, which makes sense since our target is the very first element. Let's add one more test, searching for that last element. When we run the test, it passes, and now we have 100% coverage. Great, are we done? No, and that takes us to the next tip. Tip number 3, coverage is no substitute for thought.
Oh man, I don't want to
Coverage
think.
is very useful for pointing out...
Nah, no thinking. Nah, look, what I'm thinking is let's run this test coverage. Yeah, exactly. Let's stop there. Let's run the test with the cover and see what that looks like. Hi there, Ladcade. Good morning. Good morning. Good afternoon from Australia. I'm well, thanks. I'm nice and warm in here, which is good. Yeah, nice. Winter in Sydney is actually really sunny. It's a little bit like a wet and a dry season in like tropical areas. So it's great, really sunny, nice. It's just a bit cold though. Yeah, I kind of want to think we can safely get rid of this now. Although it is a good one because it kind of does the decimal. So let's actually add that to our test. So here's a good test of our test, right? Is that we go here and we're gonna add let's add one here. So our duration milliseconds. And then we're gonna add this thing here. Oops. And the text output that we want from it is going to be ext-inf 9.967 new line new line. Cool. Okay, that works too. Now we can actually just get rid of this entire file. What do you want? Oh, yeah, okay. There we go. Oops. Okay, so that was good. So it's easy to add new tests. That's great. Let's just run this one test. Oh no, we're gonna. Let's just do cover. What was the command test? I always forget this. Always forget. We just. I'll go test. Okay, cover.
Test cases.
Yeah.
This add support for test cover. Place that.
Cover profile. Let's just do this. 51.8% of statements right now. Okay. Something. Interesting. Okay, what do we do like? Huh. Yeah, right. So this thing actually writes out. Yeah, okay, cool. Anyway, that isn't what we want. We want it in cover profile. Oh no, we got that, yeah. And then we want, what's the HTML? Go tool cover, okay? And we just give it as an argument. Go tool cover dash HTML equals this particular file. Oh. Oh. All right. Let's why is that? What? Ugh. Mode. Yeah, is that the command? Yeah, okay. Thanks. Equals cover. Oh, then wait, does that double test down output? I can't remember, file for output. Dash O, okay. Dash O. Great, okay. All right. Interesting. Oh, the fact that it... Okay. Let's choose the file that we're interested in, which is this segment. This is actually just super handy, right? All those things, yeah. Okay, cool. Let's add some tests then that do that. So we'll go for each date range, key map. So that should be pretty easy now because we can just add a whole bunch of new lines in here. So let's do segment, we got the duration we're doing, yeah. So the byte range, okay, let's try that. So we'll call this byte range. So it's going to be 2 integers, or rather we can just do a literal here. Let's do that, and then we'll go, I don't know, like from byte 69 to 420. Random numbers. And let's define what that looks like. So it should start with the XTX range. 69 at 420. Although I thought that this was being tested. I thought we had some tests for this, but Anyway, okay, close that, and then, sorry, I was just closing some old junk here. Okay, so, oh no, not that, the hashtag byte range. Oh, yeah, we do have that, okay. And then we're gonna have our ext inf is 30, 1, 2, 3. Two. And then finally we're gonna have our video. Okay, let's run it again, see what it looks like. Oh, the range. Oh, whoops, no comma. Awesome. Oh, there we go. Up it goes. Up 1 point something %, I think. Let's keep going. Doing next, we're doing the range, the discontinuity we're doing, duration we're doing. We do the key. Now the key we can actually test on its own. Pump it. This guy's mad on the crypto. It's okay. Let's do, where was our key writing logic? Whoops. Segments. No. No. Let's kill that one too. Now testing the key is going to be easier. We can even just go, because it's sort of got its own string method and stuff. It should be pretty easy. Got date range, byte range, key. Here we go. All right. Your eyes, whatever, like, you know, the magic key. The format was, oh no, and then the only other thing we need, so we're just gonna test first the most basic, like, most basic, how do we say? the stuff that's only strictly required first. So what do we need here? We need a version specification of the token set and major format one from slice. Okay, so the format versions, the example that they gave us in the spec was like 1, 2, and 5. I don't know why, but whatever, doesn't matter. Oh no, sorry, no, is that the? Oh no, we don't need format versions. We need. Sorry, we need the initialization vector. Array of 16 bytes. Okay. It's 128 bits, so. Just do some really big numbers like 10,000 and 9876543. Now we can just turn that into a 16 bytes by going the we do encode, yeah, a little endian encoding. So we're going to do the already. Encoding binary little endian. Yeah, there we go. Put. We want uint 60. No, the other way around. We want put. Yeah, that's it. Okay, so we want the IV is really going to be a yeah 16 byte, and then I thought that was encode. What is the byte order? uint64 of how to convert byte slices into that. How do we do the other way around? Byte order. Pend. Yeah, that was it. Yeah, that's it. Okay. Can put. Okay, sorry, this is just going here. So okay, here we go. Well, there's like a length of 16 elements in there. We know that. Wait. Yeah. Okay, and then we're going to do the no. We don't even need that. We can do this IV, and then we go binary dot little endian. Put uint64 IV all the way to, I'm going to put that into the slice up to there, and then we're going to put in this 10,000 just because whatever, and then we're going to do the same thing again, but then the other half of the array, which is going to be from 8 through to the end. And we're just going to put that number in because why the hell not? There we go. Okay. Okay, there we go. And then IV is just IV. And now finally, yeah. And finally, let's encode this thing. Oh, let's do if the encoded value that we want at the end of this is exec key. What's the purpose of an encrypted playlist? DRM, basically, yeah. Also, I think it's so that people can't, like DRM, but not necessarily DRM. I think there's stuff like, so that people can't just come along and like download stuff from your server straight away. So it's just sort of general, like, yeah, that sort of thing. So for example, if somebody serves a file that's got some encryption on it, then the only way for you to decrypt it would be to fetch the key and then do the decryption, which would mean maybe that you need to be like in a certain region or something like that, like a geographic thing. And then outside of that, it won't serve the playlist to people who have an IP address in, like, you know, from some country that they don't, you know, that they're not allowed to see this thing. Yeah, boring, stupid stuff like that. Money. What's the purpose of encrypted playlist? Money, baby. Yeah. Okay. Key format measures. No, we don't want any of that. Okay, so the method is going to be, when we encode this thing, we want it to be, where's the encrypt method? There, AES 128. What have we got next? The URI is going to be, oh yeah, we'll have to do this. Magic key, URI equals, whoops. And then the IV is going to be, the hex of this thing. Yeah, let's just do it like this. Should be right. Oh, yeah. know which way. Let's do it this order. It seems to be expected. Oh yeah. Ooh, up it goes, 54%. Now, we're not testing this stuff in here. And we can still do that. Let's just add to the end because it's getting a bit, you know, it's getting towards the end of the day and I'm feeling a bit lazy. I should sit up though. Okay. Now the format is going to be just a string. I don't quite understand that one. I'll just go, well, I don't know, just and the format versions should be able to, you know what? No. We do care about that. Let's get the values out, some known good values out of the spec. That's what we've got it here for. So that's format, format. Oh, key format, yeah. Indicates an implicit value of identity. Maybe we should use that just because it's kind of like the safe default. Yeah, let's do that. We could even could even almost define that as a constant. Because, yeah, I feel, you know, let's throw that in there. You know, values are like, you know, having a constant, it's not really code, right? It's just a value. So it doesn't really require maintenance. It's just there, just is. I don't mind having that sort of thing, but when you start like having code just in case, you know, logic and stuff, yeah, it gets harder. You know, you got to test it, you got to update it, this sort of shit. Hi, Dev Sitar. All that sugar's got. Yeah, I know, man. I know. Do I want some help with tests? Well, the skin. Yeah. That's the difference. That sugar's good. Right field varies starting with the tag prefix. It reminds me of Win API. Yeah, I guess because it's the actual like tag of the how do I say, like this thing here is referred to as the tag, and there's the tag attribute, and then yeah, I mean anyway, yeah, something like that. Sorry, I got distracted there. So we're doing, yeah, we're gonna add that as a constant. Okay, so let's go date range, key, put this here. Okay, again from the spec. Let's extend our thing a bit more now. So we're going to go format versions, wait, URI format. Go after URI's format. We do IV at the end? Oh no, we do format. Okay, let's do that. So key format equals AES128. And then key format versions is a quoted string 1/2/5. Oh, the key. Yeah. Tired. That's not 128. This is just identity. And it's a. Is that a quoted string? Can't remember now. Yeah, it is. Okay, so this is just identity. Nice. There we go. Looks good. All right, super happy with that. Hey there, how's it going? Exclamation mark editor. Sorry, I don't know what, is that like a command? Oh, some streamers have bots to answer these frequently asked questions. Oh, okay. Oh no, I can just, it's actually in, there we go. I'm using Acme from Plan 9, originally developed it for Plan 9. So if you go to that link there, and then there's a, there's a link to a video which does like a kind of a walkthrough of the editor and how you can use it and all that sort of stuff. Yeah, well, look, yeah, no, it's fair though, yeah. Yeah, for sure, yeah. It's good fun. I was using, of course, like just Vim and then just plain VI for years. And then I tried this one out and I really liked it. So, yeah. Never used that. Yeah. Yeah. I didn't really, because I never installed really any plugins or any like add-ons to Vim. I used Vim for like a few years, but mainly I was just using plain like VI. So, and that's just black and white, and there's no, there's no extensions or anything like that. So I guess I never checked out NeoVim. My friend was using it for a while though, and he said, "Oh man, you got to use it." I said, "Oh yeah, but I don't know." I was really interested when you could use Lua in it. I thought that was pretty cool. If that's right, if I remember rightly. Yeah, there you go. Yeah. To be able to write scripts like that is, I reckon that's really cool. Cool. Okay. What I'm going to do is just have a look at our coverage again. So if we go back to segment, I think is what we're looking. It's weird. Did we not? Let's do this again. Wait, go tool, cover, and then the HTML equals, all right, that one. And then we write it out to output to there, right? Yeah. And let's oh yeah, here we go. Great. Okay, I don't know what some caching going on, but don't know if it caches. Anyway. Sweet. All right. Cool. Let's go to right. No. It says that code isn't tested. I'm pretty sure. Oh no, it's not. Yeah. Okay. M3U8.go. Yeah, right, okay. Variant rendition, playlist type. Okay, there we go. Yeah, right, nice. I don't know why I'm checking this. I guess it was just interesting just to see the green, right? Here we go. Sorry, a few people in the chat now. More people joining. I guess people are waking up in Europe or something. Should I learn multiple back-end languages? I don't know. I guess it depends what you're working on, right? If you're writing a, some kind of program that runs on a server that, takes in some kind of, let's say it reads PHP and like writes out Go, then you need to learn 2 backend languages, I guess. I know that's a silly example, but yeah, just totally depends on what you're working on in the first place, I guess. Are there any specific projects that you've got in mind, Prime? And then somebody says, here, exactly. So what am I hacking? And anyone doing level 7 Golang intrigues me. Okay, yeah, right. This now is, we're doing a pure Go implementation of M3U8 playlist, reading and writing, basically. So this is for HTTP live streaming, or HLS. So if you're watching on Twitch, which you are, assuming you're in a web browser or something, that's how you're fetching the video. That's how, the player is fetching the video. It's using HLS. So I had a diagram up here. Go. Nice and big, because the text is not so big. Okay, is that clear? Yeah. Oh, well, I'll do it like that. Yeah. Mr. Ralloc Kaz Backwards is asking, how does HLS work with real-time video? Yeah, that's a great question. So let's just do a demo. So we'll do a demo right now. So first I'll just quickly talk through this. So long story short, this is how this stream here works. We're making RTMP, TCP connection out. We go out to, eventually we broadcast out to Twitch. We're also going to YouTube, but it doesn't matter about that right now. HLS is the bit where the player is fetching from Twitch's, HTTP servers, basically. Now, we had this idea where we thought, okay, well, that's great. Like, there's a lot of stuff there and the services take care of all that things for us. But one of the points of doing these live streams is that we're kind of doing live streaming from scratch in a way. So instead of using all these services, how much can we do ourselves? Because, we're all programmers, whether we're good or bad or awesome or whatever, there's always more to learn, right? So what we came up with was a way of writing MPEG transport stream, which is like a media container, sort of like MP4, something like that. MPEG TS is just a container format that's really optimized for streaming. It's actually invented before streaming existed. It's actually what's used in like digital TV. So when you're watching like a regular TV and you have an antenna, satellite uses it too. So there's all sorts of stuff like that. Anyway, where our OBS, does that show? Yep. This thing right here can write MPEG transport stream directly over the network without any, let's say, application protocol. So you can just use like raw UDP over the network. So pretty low latency, because these MPEG transport stream is actually just 188 bytes. It's like a set fixed buffer or fixed packet size, and so the buffering is super easy and quick. Now UDP is cool, but we actually don't even need any of IP. We can just use Unix sockets. So what we've done is we've written a little program called HLS serve, which takes in the MPEG TS over some pipe. It doesn't care where it comes from. We're using Unix sockets. And then we're chunking up the video into some segments that is required for HLS. And then because HLS is just HTTP, we're using Go's built-in HTTP file server to just serve the file straight off the disk. And hey presto, we're live streaming in like 115 lines of code or something like that. Let's run this demo. TS where it doesn't TS where it doesn't mean TypeScript. Yeah. Yeah. All the fireworks, cool. Oh yeah, great. Yeah, well, yeah. I think the first 50 times I tried to explain it was not very good, but I guess after doing it so many times, you get used to it. So yeah, thanks. 50, that's it. Yeah, 50 times, Yeah. I'm from Australia. Yeah, so I'm in Sydney, Australia right now, where it's 4 p.m. Okay, as I said, let's run this, our little command. So we have here, I need to, okay, our server's running. And if everybody has got, if everyone's got something, either if you're, if you've got a Mac, or if you've just got like even MPV or VLC is total, that's preferred really. I mean, yeah. So I'm in about 2 seconds, I'm about to paste the URL to this live stream, and let's see how our poor little $5 VM in Sydney can handle people from all over the world connecting to this thing. I'm connected via phone on Twitch. Yeah, that's cool. I'll do it here as well. All right. So we are writing. Our socket is listening and reading stuff in. Let me just check that the URL is the same. It should be. Yeah, sweet. Okay. So for anybody watching, now's the time. We'll put it into YouTube too. Sorry, Prime. We'll come back after we've done this demo. Okay. Oh, yep. People are. Oh, yeah. Okay. People are getting that thing. All right. So I'll fetch it myself. Okay. Oh, yep. People are. Oh, yeah. Okay. People are getting that thing. All right. So I'll fetch it myself. So this is just our. We should. Oh, fucking hell. Okay. There's a few people. Okay. Oh, yep. People are. Oh, yeah. Okay. People are getting that thing. All right. Okay. There's an echo. Oh, okay. I will mute my sound. Or, yeah. I think, or at least. Yeah, I'll do that. So, Mr. Zach asked, how does the live streaming work? Just gonna mute that. Right now we're watching it in a browser, but I could just as easily do it in MPV. There'll be a bunch of errors thrown because, yeah, it's a different reason, which we'll talk about at some point. Okay. Now, what's happening here is, actually, no, you know what? Sorry, let me open it up in the browser, just because we can easily see the requests that it's making. Okay. Let me open it up in the browser. So, what it's doing is it's fetching the playlist over and over again. The player, if I just show the oh no, I think I can show it in here just for consistency. Okay, all right. Here's our thing playing. So what happens is that where it knows that it's, the first thing it knows about whether it's live or not is this playlist type here. So event means live in HLS land. And if it's not live, it's VOD, VOD. So that would be something like, you know, you're playing back something that's already been recorded. This bit here tells the player that that it's going to try to get every segment, every video file to be 2 seconds long. So that kind of, it knows then, oh, okay, well, it's live and then things are going to be 2 seconds long. I'm going to keep fetching this thing, you know, every, let's say, second or something like that to you know, to get where I'm up to. That bit, don't worry about that. Yeah, so it actually just keeps fetching the playlist and then we'll just see. So next time it goes 074 and the next time it fetches is 75. So it fetches a playlist, gets the next segment, fetches a playlist, gets the next segment, over and over and over again. That's it. It's pretty dumb, but hey. If I just go back to VLC explodes. Oh, really? Yeah, right. Weird. So, see, yeah, there's some problems. The problems are that the way that we're chunking up the video isn't really very robust. But that's what makes it so, that's what makes the program so small. We're literally just counting the bytes. And yeah, so we're just slicing, we're saying how our server actually works is every 2 seconds, it'll just flush whatever's in the buffer and write it to a file. And it makes sure that it cuts it on a boundary that's 188 bytes, which is the packet size of, well, it has to be that size based on the MPEG transport stream thing. Otherwise, we're cutting in halfway through a packet. So kind of a sort of a cheap hack, but it mostly works. I'm kind of hoping that if you play it on VLC again, maybe it'll work better. There's other latency issues as well, so yeah. But yeah, there we go. So that's now in the real world, we're not going to be generating the playlist over and over and over again. We're going to be heavily relies on caching. So if we go to, this is your sort of typical kind of live streaming architecture thing. So we're down here with the actual, video and audio. We're writing out, we're kind of doing something that looks like a local wired stream, which is, we're not using an application protocol, we're just using raw UDP or even Unix socket. And then we're not doing any of this. We're just doing, because we're just passing through the encoding. So we're not doing, we're not downscaling it or changing the codec or anything like that. We're doing the manifest creation. Manifest creation is another word for the playlist. And then we've got our origin server, which is literally this computer like sitting here in front of me. Now, normally these things rely on, nice big juicy CDNs to serve the bulk of the traffic. Anybody who's done stuff with, with doing like just serving HTTP files, lots of them, will probably know about all the different types of caching techniques that the CDNs rely on in the HTTP protocol to kind of, make sure that basically nothing ever really gets to the origin server. So in our in our server, for example, we could say, hey, like cache this thing for, 60 seconds would be fine. The Go file server, the HTTP file server, by default does things like it serves the last modified time in the HTTP header. So when we go to, if we take a look at our file system, we've got a whole bunch of files that are continuously, I'm not pointing the screen, but see there's 256 now, and then we should get 257. There we go. So as we go, we're writing out more and more files. So, so normally it wouldn't just be like hitting my computer all the time, nor would we be like having to generate the playlist. It would just serve it. It would just some super performant HTTP, like caching HTTP server like Varnish, running Varnish or something like that. That's from things like Cloudflare, Fastly, Akamai. They have a whole bunch of these things that can just serve a bajillion bytes at a time. There you go. So you cache, manifest, and segment, and then there. But doing it raw works just fine. It's just that it gets pretty, if you can imagine, because this is all unicast, depending on how many people you've got watching it, you're serving a lot of bytes. Very, even with like, if you go from 10 to 20 people, that's doubling the bandwidth. Whereas in the old sort of broadcast world, for example, if you're doing MPEG, TS, and digital TV, that's a lot easier in the sense that you just need to have like a fat fucking antenna, and whatever it's pumping out, it can go to one person or 1,000 people. It doesn't matter. Whereas in the IP world, it's, yeah, you need all sorts of stuff to make it kind of work. Yeah. I've been waiting for us watching your VODs and this feels like spoilers. Yeah. So your stream on Twitch right now is also self-hosted. Well, okay. Oh, so this particular stream on Twitch, yeah, I'll just show how that works. If I close that up, I'm going to close that up. Go here. All right. Now, how it's working right now is we're using a protocol called RTMP, or real-time messaging protocol, that runs over TCP. Now, right now what I'm doing is to simulcast, or like to send the video to Twitch and YouTube. I just have a little FFmpeg process running right here. That's been going, what, for 5.5 hours now? Yeah, and what this does is it reads in one RTMP stream and then just has a T writer that just manages 2 connections and forwards the bytes to both of them, and then manages the connection to both Twitch and YouTube. So that's like a, you know, like the command is, it's not one of these big crazy FFmpeg commands. It's only like very small. A couple of, what have we got, like 3 options in there or something. And then Twitch and YouTube do all the other work that we were doing here. Because with RTMP, you're just sending just one sort of big long video and audio, and then they do all the work of cutting it up and making a playlist. One way to do it is, my stream will stop if FFmpeg stops. Yeah, yep, absolutely, yeah. So if I send a, you know, interrupt, like a SIGINT to it, then yeah, the connections to here would close. And yeah, FFmpeg and small commands are I could, hold on, let me answer. I know, yeah. This has got my stream keys in here, so I won't show this, but I'll paste that. That's the command there, so not too bad. So of course we hide the banner because that's just that copyright thing that it always shows at the beginning. We're specifying the container format, which is Flash format. Listening on the loopback interface, so on localhost. Leave that to the next. We're just saying, hey, like, don't use any, don't re-encode. Just copy whatever codecs you get. In this case, it's H.264 and for the video and AAC for the audio. And then this thing here, that's a way of telling the That's a way of telling FFmpeg to manage the RTMP connections to Twitch and YouTube independently, if I read the documentation right. And then here's our bit where we're doing our T writer. So we're saying send it to Twitch and YouTube. But yeah, I think these FFmpeg commands are, even this to me is like super ugly, because I'm thinking like, hey, like as a Unix guy, I'm like, well, like, where are the pipes, or why aren't things split up? It's just like a shitload of options. Yeah. So that's that bit. Now there is another way to do it. You can have it, yeah, it's, so I actually wrote a post to the mailing list about this. If I, this thing here. And for, oh, I posted to YouTube as well. God, I really need to get YouTube into. And yeah, so I went through I just wrote an article on the problems that we were running into, stuff like that. Yeah, so that's the other way to get this working now, to be even more sort of like self-hosted, we can we do that? Yeah, we can rip FFmpeg out and actually ask both Twitch and YouTube to pull HLS from us. So instead of having it where we connect to YouTube and Twitch, we can say to them, hey, we've got an HLS stream here. I want you to rebroadcast that. So they'll pull the stuff from our server, in the case from like literally my computer, and then just kind of, yeah, and then serve it on their own servers. The thing is that introduces more latency. And that kind of sucks for this kind of thing, because you want to try and keep the latency low because people are speaking to you, and like I think it's really cool that people are talking and stuff. But it would be sort of conceptually a lot simpler. And yeah, absolutely, like no FFmpeg, no RTMP, that sort of thing. There's a new specification of HLS that's in draft status at the moment called low latency HLS. And the idea there is to, yeah, as it says, reduce the latency. At the moment, HLS, every time you fetch one of these files that I had somewhere here, in the HLS spec, they say that these cannot be shorter than 2 seconds. So pretty much no matter what you do, you're always going to have 2 seconds, which is like not terrible. But if you want that really low latency stuff, there's many sources of latency, what they call glass to glass. So that's from like me actually speaking to the camera and actually the sound, getting into the microphone, into the preamp, going out HDMI, out into the blah, blah, blah. All the buffering in between. Yeah, it sort of adds up. So low latency HLS gets it down by being able to essentially, yeah, like being able to split up these segments into something even smaller. There's a whole bunch of other stuff that's involved, but I don't actually know. I'm not actually sure. I haven't read the spec yet. It might be interesting though. But yeah, if you're interested in this sort of thing, of course, I'll be going through it, but I can only go as fast as my mind can allow, which is not super fast. And because I'm kind of talking and writing at the same time and all that. This is a sort of a like group hosted by mux.com. And they, they host like conferences and have a bunch of useful documentation, and they're like, one of these Silicon Valley startup things, but they're pretty big now. Yeah, so that's, yeah. How can I build a decentralized streaming service? Ooh, decentralized. I can't remember. How does PeerTube work? Was it PeerTube? That's not really what I want. Yep. I would look at this one, Mr. Toma. That'll give some interesting, yeah, no worries, Maniac. Thanks for, thanks for coming by. Yeah, see you next time, whenever that is. This PeerTube is interesting. So this one actually uses BitTorrent under the hood to kind of send around video. I think that's, yeah, in terms of it being decentralized, I think that's a pretty cool idea. So I think the way it would work is that what we're all watching right now, we would all be seeding these segments to each other. So of course, people would be getting it from me first because that's where it comes from. But then you'd all be getting it from each other after that. So I think that's a pretty cool idea. Especially because video is still pretty hard, you know, like it's still, how do I say? You know, we've had the web and websites, you know, for ages, but video is still, you know, YouTube is so big, and yeah, like there's just, and the ones that aren't YouTube, I mean, they're all heavily dependent on a small number of companies like these CDNs to operate. So something peer-to-peer would be, yeah, is very cool. Yeah. Yeah, but you know, it's if it, I mean, using BitTorrent, yeah, but also, yeah, look, like if we can take the core sort of bits, for example, I have all these files right here. Let's, peer-to-peer, that's pretty hard. But I think something that is probably easier to reason about is just like mirroring files. So if you could think of a way to, you know, have, let's say, for example, if you look at other projects like NTP, like the NTP pool project, there's things like, but I guess what I'm getting at is that to have it work kind of seamlessly, like in the browser and stuff, okay, like that's one thing. But if we can just get a way to, you know, distribute these files, that's a lot easier to think about. I think there's a bunch of different ways to come up with that sort of thing. For example, we could have a set of servers that pull in the files and then just serve them again. Right now, I'm just using one single VM that's a reverse proxy from from Sydney, but we could have 10 servers around the place, all pulling in those files. The way I would really do this that I think would be easy and a lot of fun would be using fly.io. So they do, yeah, some interesting stuff in relation to this kind of thing. So they make that bit where you have, let's say, just some HTTP file server, and then they give you an Anycast address. So what I mean is, if people are familiar with Anycast, but the idea is that you just hit one address, let's say live.olo.co, and then you'll have your request served by something close to you. That already spreads the load quite a lot. So that's probably, that would probably be, a fun little project to use fly.io to do like some of the harder, like to get around some of the trickier networking things, because to get your own, Anycast address and all this sort of thing is pretty hard. But they can get you that. Installed Acme Chinese. I really like interface and learn easier when watching the streams. Do you have to use touch to make new files from buffers? Do you mean like, say you have a window and then you want to be able to save that file somewhere? Is that right? Okay, so the way to do it is let's say you just have a thing like this. You just see how in each of these windows I've got the name of the file. So what you do is you just put here and you just say, okay, I want to write that to like, Zach.txt. And then you just do that, and then the file's there. Ah, okay. Yeah. Yep. And the same goes now, let's say if I have this here and I want to do another file, let's say Zach, 22, I just edit the file name and then that's it. Yeah, you do, yeah. Because it doesn't know that, let's say it doesn't, because it doesn't handle renaming, I guess, or moving files. No, arrow keys? Yeah, that's right. Yep. I know, it's a weird experience, yeah. So you can have arrow keys left and right. Okay. But up and down scroll the window. Now, I think the purest would be that, up and down, let's say there is no up or down in a file, because it's just a stream, it's just a text stream. So where is up and where is down? If that makes sense. It's if you think about it, it's like, oh yeah, okay, that kind of makes sense, but it's just a weird thing because it all depends on the size of your window. Yeah, it's just, if you do want to do it, you just click with, you just click. But yeah, I mean, it makes sense in a way that you go, okay, I understand that, but you know, I don't know whether it's the most usable thing or whether that's the right thing or the wrong thing. These things are just kind of like mental exercises. I'm not very, I'm not super puritanical about any of that sort of thing. Or about anything really, to be honest. Yeah, so. Oh, this thing's still recording. Hold on, let me kill the recording. Yeah. Oh wow, I just realized that the camera's super dark. Hold up, I forgot to. There we go. And then we'll do this one. It's open. Yeah, there we go. Okay. Great, good fun. Okay, so we've done that. Let's take another look at, let's just remove all of this. Just another thing. The other thing is that, no, that's, yeah. No, it's good. Acme's fun. When you're using it with Plan 9, then you start to go, whoa, okay, this is a different, yeah. But it's okay using it on Unix and stuff too. Now that we've got more tests done, I feel like that's pretty good. Let's actually just, let's commit this stuff. Motherfucker, how do you wanna restore? Let's just get, you know, every time you stray from the usual. Any file known to get. Oh yeah, okay. I need to do that and then files known to get. Yeah, that's okay. I'm all right with that. I just want to not reset. That changes the. What? Oh. What is that? Is that a command? No. Oh, that just means that. Yeah, okay. Oh my god, fuck this. Alright, let's just commit them on here anyway. So we got that. Let's go right, okay, so and segment.go. So by doing this, why are we doing this change? To make it easier to add new tests to test. Oh no, to add. And let's say, oh, we're going to do that as well. There we go. Great. Okay, let's send that up. Which keyboard do I use? I use this Ducky Shine, is it? Ducky Shine. It was just the cheapest Ducky keyboard that I could find. It has all these lights and stuff, but I have all that turned off because I don't like that. But it was just the cheapest one, but it's pretty old. Like it's about almost maybe over 10 years old now, but still runs great. And it uses cherry brown switches. It's cool. Normally I use the cherry blues, but that keyboard's too long. Since I use the mouse quite a bit now, I don't use that keyboard so much anymore. Yeah, but the cherry blues are really cool too. You know, I like to get that real click. It's good. Great. Okay. Just reading through these recommendations. Yeah, I mean, I'm not doing these exhaustive tests, that's for sure. Yeah, okay. It's pretty good. What's the time? Oh, yeah, okay. How long have we been going for? Ooh, just hit 6 hours. It's good. I'm just thinking what else I wanted to do. Yep. Of course, the big thing I want to do is write some documentation and examples and stuff like that. That's when you really start. Also, it's another way to get a feel for if you've got the interface right for the package, is when you start documenting it. I think that's one of the things about documentation is that it's not like, of course, you don't really want to write documentation, but it's kind of a thinking exercise where if writing the documentation is really hard or it really, really sucks, then maybe it means that the external interface to whatever the thing is that you're documenting is not quite right, or it's too complicated, or it's too difficult. So if you've got some function that takes like 10 arguments and you have to like document each one, you think, geez, like of course it sucks documenting it. Maybe because it's just the function that sucks. Tell it. Smoko. How do you know about it? I thought that was like an Aussie expression, the smoko. Kick from Australia. Hey, booking 294. I don't know. I don't even know what kick is. Yeah, nice. How did you know about Smoko, that kick? Rewarding that signed XQC for 100 million. XQC? XQC. Oh, it's a person. Oh, yeah, I've seen this person. Yeah. Okay. And they signed, like an exclusivity deal? Okay, interesting, yeah, okay. Just like the good old media world going for the, yeah, okay. How do I, here we go. Here we go. Ashwood Holdings, Edward Craven. Oh, stake.com. Yeah. Okay. Nice, yeah. Okay. I might, so for, pretty much what I should do is, since we've kind of done like most of the coding stuff, I'm getting a little bit fried. I think that what I'll do is I'll put it onto, let's put it onto this. Now I'm going to stay online on Twitch just because yeah, people, like a lot of people seem to watch the YouTube stuff after it's live streamed. So if anybody wants to, yeah, because I don't like to keep all this fluff there because I'm, you know, waste of bytes. So I'll just go quickly onto YouTube and just say, anybody watching, like, thanks heaps for watching. Thanks for the questions. Thanks for the help. Thanks for the donations. Thanks for following. Thanks for subscribing. Thanks for, you know, whatever. Thanks for saying hi from the other side of the world. That's just amazing, right? I'll be doing a talk on in about 48 hours about this stream, but also about the text editor, and I don't know, just a bit of a story about how it all fits together, because I think it's a funny story. And that'll be at the Go programming language meetup in Sydney. So if anybody here is from Australia and is in Sydney, come along to that. It's on Thursday night here. But yeah, it's in about 48 hours. So I'm going to see if I can stream from there. Like, I've got the camera, so I should just be able to put it there and have it running, but we'll see. Yeah, as always, if you've got any other like thoughts or suggestions or ideas, anything really, like, or if you've got any questions, yeah, just write them to that email address. And yeah, or in chat also works. But yeah, that's yeah, I think that's it for now. So let me just go into YouTube here. I don't know how to do this still. Control room. Here we are. Now, for anybody who wants to keep watching, I'm going to keep going because I've got another hour or so. I'm going to write to there. Is that right? Yep. We're going to keep going on Twitch. So if anybody wants to hop over to that, then... Oh, here we go. I'm my 18-year-old I to the car. Hey, how's it going? Yeah, yeah, so anybody wants to, I don't know, we'll just hang out or just work stuff out. But yeah, anyway, just want to say thanks again, and we'll see you next time. I should be on tomorrow. Oh, and of course, I should always say, remember, if anybody knows anything, because I'm also looking for a job, right? So if anybody knows anything, get them to send me an email. That would be awesome. I'm super easygoing, so yeah. All right, cheers. Thanks, everybody.